fill in the P of x equals to give a legitimate probability distribution for the discrete random variables. Possible values are these. So the thing that you have to remember is that all of these numbers on the right, all the probabilities, they have to add up to 1.
Add it to
So we first need to add up those two numbers, or those three numbers. So I'm going to do that now as well. 0.29 plus 0.16 plus 0.28. And that's 0.73. So it doesn't say anything about like these two boxes as far as like their relationship. So we just know that they have to add together. We call it X, call it Y to get 1. So, you can split up however you want, like maybe go 0.13, 0.14, and that'll do it.
Okay. Great. I'm going to share the next one.
But sometimes they tell you something like they have to be equal, or one is greater than the other or something, but this one does not. This is actually very, very similar here.
Okay.
You want to first add up those three numbers, and you can divide up whatever you want.
The first three or the first four?
I'm sorry, the 0.29, the 0.19, and the
Oh.
0.30. So you can add those up. And so that ends up being a 0.78. And then you can split up. What's it? Did you add up all three?
Yeah. Oh, hold on.
You got an extra zero there. And then uh, and then you can subtract that from 1. So you do a 1 minus that number.
So,
Very good.
minus
Yep. So
three.
now that can be divided up between the two of them. So you can just do divided by 2 and put 0.11 in each position.
0.011 for both.
Yes, yes. And so the idea is that the whole thing adds up to 1. So one more here of these. So add up those three numbers.
Four, and so then we're going to do the 1 minus
Yeah.
0,
Right.
1.
And then you can divide that number by 2.
Did I mess something up?
Yep, that's good. It doesn't divide it, so it's just 3 decimal places, 0.255. I assume it'll let you enter that. Yeah, well, I don't know why not, but yeah.
So then this other one that I was struggling with, all in the bottom. So I was getting.
I'm gonna just step away for 10 seconds. I'll be right back.
Sure.
I'm back. Okay.
Okay. So with this one, I know that I have to do like the P with the Z to get like the 1.51, but it's the shading is where I'm getting thrown off.
Yeah, so you've got to grab that vertical line, that middle tool there. Yeah, that one, vertical segment, and you want to put it at 1.5. We want it to the right,
Yeah.
right there. See where it is in red? Right there, perfect.
Okay.
And then grab the shade tool. And so when it says under means to the left. So just shade left of that and just click in there. There you go. And then I don't know how you're calculating that value.
So
You got a normal calculator somewhere?
yeah, so I was reading like in the expiration,
Oh yeah,
like
yeah,
it
exactly.
told us to
Yep.
use this. So I got all that part. It was just it's the shading part is where I'm getting thrown off.
Okay. So let's get the wording down here for the next one. So to the left of z equals minus 0.5, or you can do that first.
And then, just a calculator.
So grab that vertical line. You got a minus 0.5
Okay.
between 0 and -1 to the right.
Oh,
That's minus 1.5. Yeah, where you have it. Just be careful there.
yeah, right here.
Yep, you got it.
All
And
right.
then it says to the left, so you're going to fill in to the left of it. There you go. That's it. All right. I'm going to just again step away for 10 seconds, but I'll be right back. Go ahead
For
and
sure.
look at the next one.
Sounds good.
All right. So this one is to the left of 2. So you want to grab that right there at 2. You're at -2.
Negative
There you go. You know, you want to do that. You're at the wrong, you don't want to do that. Yeah.
at 2. Right here.
That looks good. Yep.
Okay.
And then shade to the left of that. All right. Good job.
And then before we jump on like the new ones, I want to get the ones I was mostly struggling with before we move on to those other new topics. So I was struggling with this one.
Okay. Let me grab a snip here and
Okay.
work through it. These are substantially easier than the ones we were working on the other day. That matters. All right. When you read through this, you have to identify the information they're giving you. They're telling you the mean. That's X bar. That's sigma. And so you have to be able to calculate what's called a z-score. And then what we're doing is trying to find the probability that X is between 720 and 1000. So, and that comes from here. So to do that, um, actually, could you tell me what's in the drop down here?
Yeah, it
It looks
is
like this.
68%,
I see.
75, 95. And then, yeah.
I see. I apologize. So this is actually slightly different. So imagine 860 is in the middle, and if we go out 70, that's 930, and go left 70, that's 790. That's one standard deviation.
Okay.
And then if we go out another one, so another 70, so that's 1,000. So, and then we go the other direction here, that's 720. That's two standard deviations away. Do you see that? How I'm getting that? That's the 70
Yeah.
is the standard deviation. So there's this thing called the empirical rule, which says that a certain percentage of data falls within, one or two or three standard deviations of the mean. All right, so let me actually grab a snip of that, and then the problem's gonna much faster. But I'll grab an image of this. It's a pretty good one. All right, so they're trying to show you again that like I just showed you here, that 68% of the data is within one standard deviation, 95% of the data is within two, and 99.7% of the data is between three. So in terms of your answer, it's 95% here because this is -2 and this is +2 standard deviations away.
Okay.
Okay. And then the 99.7 here is three standard deviations away. So we have to go out one more standard deviation on each of these. So that's 1070 and 650. So it's between 650 and 1070.
I'll share for the next one. So, yeah. So the lowest number, that's the standard deviation. Okay.
Well, you start right in the middle at 1170. And I'm going to grab a snip of this one.
Okay.
Normally in a classroom, you would have a curve and you would actually draw this, but we can just shortcut it a little bit here. So the idea is that right in the middle is 1170. And then if we go out one standard deviation in each direction, we're adding 300 to it and subtracting 300. So that's 1470 and then 870.
Okay, so that's where it's getting thrown off. Okay, so
And
you're
if we got
adding.
another, yeah, if we got another, that's 1770 and then 570. And if we got another, that's 2070 and then 270. So you can see that to get to 270 and 2070, that's 3 standard deviations, and that's 99.7%. 90 for the second one for 95%, that's between 2 standard deviations. And each of these is, this is one, this is one, this is one, this is two, this is two. You can see that it's 570 to 1770.
Mhm. Okay, I'm gonna try the next one. So let's see, maybe if I get it wrong, just let me know.
Yes, of
Okay,
course.
I'm gonna draw them wrong. So I think I think I've got B, but I'm getting thrown off with A.
What
So
did you
I
get for
got like
B?
for B, I got I'm assuming 95% because of like we're subtracting 90, right?
Yeah,
I'm,
so
I'm
it's really helpful to draw the picture here. So you can see
yeah,
that
that's what
105 and 10 and 159 are 3 standard deviations away, plus 3 and minus 3. So that's 99.7%.
uh, 90. That's I was trying to think of the chart.
68% is plus or minus 1, 95% is plus or minus 2, 99.7% is plus or minus 3. So if 68% is one standard deviation away, you can see that's 123 to 141.
I'm more like the chart really helped. Yeah, I did that, but I just gave yeah. Okay, there we go. And
So you can
then
share your screen whenever you're ready. We can continue looking at problems here.
skip. Let me just skip through this one really fast.
Right, so these are just using the same calculator that you've been using,
Okay.
and I'll take a look and see. They've got just the left. Okay, that's good. So that'll impact the second one, but just put in minus 1.51 for that. So for the next one, it says greater than minus 0.56. So you'll notice that if you go back to your calculator, you only have a less than.
Yes.
So you use that, the less than. Go ahead and use that less than again.
Mm-hmm.
But you're going to put a 1 minus in front of it.
And
In
like
front of
right next to the Z.
No, in front of the P. So you're going to go all the way to the left there, in front of that P. Yes, and do 1 minus. So that'll give you the rights, what's called the right tail.
I don't think it's gonna let me like click to like right in front of the
Okay,
P.
so maybe undo or clear it out and then do a 1 minus there first.
Then do it.
Yeah.
And then,
Okay. And then for this one, you're going to do two of these. You're going to do what's called right minus left. So go ahead and clear that out and do the PZ thing again. And then 1.58. And then go to the right of that, all the way outside the parentheses, and type in minus, and then do the PZ again, and then 0.37. All right, good job. All right, so for part A is a 1 minus because it's a greater than.
so whenever it's greater than, do the 1 minus.
Yes, exactly. And that one's just a straight on less than.
Yeah.
Good.
Then this is when we do the 1 minus
No,
P.
this one, this is two of them. It's right minus left. So you're gonna do the 1.73 first, the PZ 1.73,
So,
and then go to the right of that and do a minus, and then grab that PZ again, minus 0.57.
So for since it's less, uh,
You're no longer sharing.
yeah, sorry, the screen. Oh, you can't see it.
No.
My screen turned off.
Since it's greater than, that's a 1 minus.
Yeah.
To the right, you've got an extra 0 in there. Yeah, there you go. Yeah. Okay.
Did I enter it correctly or did I forget the one?
No, that's the between. It's 1.99 minus that. Yeah, looks good. All right, good job.
Um,
All right, so let me grab this. This one's a little bit time consuming, but
okay.
it's very repetitive. Meaning, once you see one, you don't do the rest. So
Okay.
to find what's called the expected value of X it's actually the mean. To find E of X, you take each of the X values and you multiply them by the probability, but then you add them up. So it's plus, the next one is 0 times 0.55. So if you see here, I'm just going across here, I'm taking that X value times that X value times that one, plus 1 times 0.15. I run out of room pretty quickly here. 2 times 0.05, and then 3 times 0.1. So you'll want to grab a calculator or use your calculator for that. I'm also going to create a little thing here to, to do these a little faster for us. Um, 0.15.
So I got 6.45.
All right, yeah, give me just a moment because I want to be able to do these faster. And
Okay.
that sounds reasonable. No, that sounds way too large, actually. It should be somewhere between like 0 and 1.
So do
So
you
I
have to
guess
enter the parentheses when you're doing it in the calculator?
no, I just make sure you got all your decimal points. I just do that for like visualizing
Mhm.
where they're separating the numbers. Right, do these actually? Okay, so all right, yeah, so I got 0.4. Right, so that's the first box there. To do the second box, you have to do a really similar calculation. It's called the expected value of what's called X squared. And it's really, really similar to what I just did,
Uh-huh.
except this time you square the X values. So you square all the X values first and then multiply. So
Okay.
like what a lot of students will do is they'll square it and then multiply. Because it's an easy square in most cases.
Mhm.
but that's only part of it. So that's the first part of it. So that's the next thing you need though. All right, so that ends up being 1.4 when you do that. Okay. So the variance formula is the expected value of x squared, so what I just found, minus the expected value of x squared. So you might be like, well, what's the difference? Well, it's 1.4 minus 0.4 squared.
Oh, okay.
Which is 1.24. It's very recipe based, very much like, you gotta do a few of them in a row and then you'll have it.
Yeah, you get it. I think probably where I'm only getting like throwing myself off, I think, would be the adding like it all together because I got like a different number. I kept getting the 645.
Okay, so let me grab one more here. And
Okay.
the parentheses are only just for showing kind of the separation of the numbers. So the expected value of x is you take the x value 3 times 0.15 plus 4 times 0.15 plus 5 times 0.55 plus 6 times 0.15. So give that one a try.
All right. Mm,
Let me know what you come up with.
and that's times, right? Right in front of the three
Yeah,
times.
yep, that's a
Okay.
multiplication, yeah.
So that's what I was doing wrong. I don't know. I got a high number. I got 16.3.
Because you must be missing a decimal or something. I mean, it's got to be it's got to be in the range of these numbers.
Let me double. Let me
So
put the
3
zero.
times 0.15, 4 times 0.15. Like you don't have to put the zero in, by the way. I noticed you were doing that earlier. 5 times 0.55, 6 times 0.15.
It looks the same. I mean,
All
I
right,
don't know.
why don't you share your screen? Because and I'll share mine back here. I mean, I'm not going to leave you without getting the numbers, but there's something clearly wrong with the calculation here.
Uh-huh. So I got 3 point.
Right. So you in your next to the 4, you have a plus. It should be 4 times 0.5.
Oh, times, not
And
plus.
then and then and then plus 5 times 0.55. You got to remove that plus there. Yeah. And then it's 5 times 0.55. You get a plus there.
Oh, it's times. It's not plus.
Yes.
Okay,
Yeah.
so
And
that's what I was
and
doing.
then and then the 6 times no, that's a plus. That's a plus. You're losing your numbers there. It's 0.55 plus 6 times. So the parentheses on my screen, there you go. Hit enter on that.
Okay.
Yeah, 4.7. So on my screen, I'll share this now again. The parentheses indicate multiplication.
Oh, okay.
So 3 times 0.15, 4 times, like if there's nothing here, it's considered multiplication.
Okay, yeah. See, that's what I was getting to about.
Yeah. So 4.7 is correct. Then the next thing you have to find is what's called the expected value of x squared. So you square the 3 times 0.15 plus 4 squared times 0.15 plus 5 squared times 0.55 plus 6 squared times 0.15. So you should be able to go back in yours and just add in a square to each of these numbers. and get the new one. Would you give that a try?
Yes, I'll let you know when I get. Um, so 20, I got 22.9.
Yes, very good. So now the variance of x is the expected value of x squared minus the expected value of x squared. So it's the 22.9 you just found minus the 4.7 squared.
So 18.2. Oh, no, I did square, sorry. Let me square that one. 0.81.
Yes, perfect. So there you go. Now you've got both numbers.
I'm sorry, hello, my screen. It's not loading. It's being weird.
All right, looks good.
Yeah, I'm saying, hold on, my screen, it's not loading. It's being
Oh
weird.
no.
I don't want to refresh it and then lose
Yeah,
it.
I wouldn't, but you may not have much of a choice. Yeah.
I'm trying to refresh
Something went wrong. Yeah,
it.
something went wrong.
Let me hit reload.
Yeah, try reloading. I'll give you. I'll do it quickly for you if it's something like that. All right. So it's the same number. So it's 4.7 and then the 0.81. Right.
Should I try a different one and then I'll try
It's up
that
to
one on
you.
my
Yeah,
own?
it's up to
Yeah,
you. Yeah.
I'm gonna try a different one and then I more or less know what I'm gonna do now for that. We're
Yep.
gonna times it and then and plus it and then times it. I don't know why it's not loading for me.
All right. It's not good. If this problem persists, we'll make some other arrangements. But maybe
No, I think
got it. All right.
we got it. Yeah.
Okay. All right. So let me grab a snip here. So the mean of a binomial variable, which is what the first box is asking for, which says it has a lot of words here. So the mean, or what's called the expected value for part A, the expected value of x is the value of n, which is in your problem is 20, right? And
Mm.
then the probability and what's called n times p. Now it says that they're equally likely to win. That means there's p is 0.5. So 20 times 0.5 is 10. Okay. Now the standard deviation of a binomial variable is n times p times 1 minus p, but it's the square root of that. So that's 20 times 0.5 times 1 minus 0.5, square root of that. So it should end up being the square root of 5. And then you got to round that to 3 decimal places, it looks like. So I get 2.236.
One second. Mhm. That's what I got. Two. Hmm. I'm going to move on to a different topic.
Okay, that's fine.
I'm just going to refer back to the videos if I
Yeah, sounds good.
struggle with it. Um, so it's,
So let me grab a snip of this. When we started doing the empirical rule, I actually was trying to do a problem like this. So with the we've got the mean, we've got a standard deviation, and we want to know less than 78. So we want to find the probability that x is less than 78. So to do that, you have to calculate a z. Z is x bar minus mu over sigma divided by the square root of n. We assume that n is 1 unless we're told otherwise. Like if they don't tell you how many, you just go with that. So x bar is 80, mu is 78, sigma is 8, square root of 1 like that. So we calculate this value. That's the z value. And
I don't
if
think you're
you're
sharing
oh,
screen.
I'm not sharing. That is true. Okay. Sorry about all that.
It's okay. I was like, wait, what?
Yeah, you'll see it here. So the once you get the z value, you're going to use that pz thing,
Okay.
like we were doing before. You can actually do this calculation inside that pz in your but I mean it ends up being nice, but it's 2.25, and then you just go to your normal pz thing and 0.25 true. So you end up getting 0.59. Does it say 4 decimal places? All right, so this ends up being 0.5987. 5987.
Maybe I'm entering around, but 0.987, correct?
It didn't like that, did you saying it didn't like that?
No.
80 minus 78, 70. Uh, oh,
I could read
sorry.
on
I
the
I
yeah.
got the I got this reversed. Sorry about that. It's 70 minus 78 minus 80. Um, sorry about that. So it's
Okay.
negative 0.25. So it ends up being uh 0.4013.
Sorry, what was it? Point.
Okay. Uh uh 0.4013.
It threw me back. So there you
I
go.
don't know. Yeah, I'm not seeing your screen, so
Yeah,
yeah, that is the answer. I don't know.
yeah. I think I entered it wrong, so it just
Okay.
threw me
All right.
back. I think okay. There's this topic open before our time runs out.
So let me grab snip here, share my screen. All right. All right. So they're normally distributed with a standard deviation of 16 and 58% of the individuals with these numbers score greater than 100 and 42% do not. What is the mean IQ score for this region? All right. Okay, so normally it's x x minus mu over sigma. That becomes your z. And they're saying in this problem, they're saying that the probability that scores are greater than 100 is 0.58, which means that the probability that the scores are less than 100 is 0.42. So you have to find the z value corresponding to 0.42.
Two.
So to do that, it's a reverse lookup, and I'm not sure how to do it on the Alex calculator, but in my case here, that number is that z value is minus 0.2019, and then your x is 100, uh, and then we're trying to find this mu over sigma. So to solve for this mu here, which we're looking for, it ends up being and sigma is actually 16 here. Let me put that in. It ends up being 100. Uh, I don't want to do this. It ends up being plus 0.2019 times 16. So that ends up being 103.23 when it's rounded. It's kind of a backwards calculation, backwards problem.
I mean, I'm more or less understood it. So um, could we do one more and
Sure.
then
Yeah.
we'll
Yeah.
be done?
Sure. Whatever you'd like. Um, this one is similar. Let me go ahead and grab a snippet of it. Sorry, my energy's a little low today. Not sure why.
It's okay.
I'm a little bit off myself.
It's the
So
sickness going around.
suppose that the scores are normally distributed with standard deviation of 90. That's sigma. Exactly 10% of the scores exceed 100. So the probability that x is greater than 800 is 0.1, which means the probability that less than 800 is 0.9. So we want z of 0.9 because you always go to the left. That's x minus mu over sigma. And we want to find the mean distribution score. So it's just like before. So the mu is x minus z 0.9 times sigma to do this. So uh, we, their x is 800 in this problem. And then that z of 0.9, that's a lookup in a normal distribution table. It's an inverse norm lookup. 1.2816, 1.2816, 2816. I do it 2. All right, times sigma, which is 90, 90 like that. So This isn't right. Sorry, this is a plus. No. We're trying to find mu. 10% of the scores. Sorry, this should be a plus. Wow. Wait a second. No. It is a minus. I'm sorry. It's a minus. All right. So 684 ends up being 684.7. 684.7 for that.
Okay, great. Thank you, Matthew. I appreciate all your help.
Yeah, if you don't mind, hang on just real quick here.